Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. We're glad to see you in ICST event 2022. Let me here to present our paper, The Tension Stiffening Stress Strain Relationship of Concrete in Tension, Newly Developed Test Methods and Implementation. First, I will introduce our team's authors. Here are Mr. Dr. Engineer Nuraji MS, Muhammad Agung Diprawiro as me as a presenter, Professor Suan Tehu from Taiwan, Professor Dr. Engineer Michael Lee Han, Magister of Engineering from Diponegoro University Institute. Okay, next we are going to the introduction first. What is tension stiffening effect? Tension stiffening effect, as general, is increasing of stiffness over crack sections based on ability of concrete in between cracks to resist tensions. The tensile strength of concrete can be determined by several different test methods such as flexural, splitting, and direct test. Practically, tension stiffening is a phenomenon in reinforced concrete to control deflections, crack spacing, crack widths, and the formation of multiple cracks. The location of the cracks determining the tension stress carried by the concrete at any section. Okay, here we come to the next slide is the methods for the experimental investigation that we are modeled in cylindrical reinforced concrete with symmetrical and treatment with several control conditions mentioned on the table below. As we can see from the table of specimens, we categorize from code, concrete strength, FC in MPa, length in millimeters, steel bars diameter in millimeters, and steel strength or F yield in MPa. For the concrete strength is the actual strength after we make a compression test. There are 32, 40, and 46, and the length is 450, and steel bars is various, and the steel strength is not very relatively close each other. Okay, we able to see here the dimension of the specimen is 125 for each side and 450 for the specimens, and the diameter is 101.6 millimeter, and in the middle is reinforcement bars. Okay, go to the next slide. In the next slide, here we try to introduce you about our setup. Our setup is quite special. Here is the LVDT and the rod and the clamp. We creating our own test setup to able support our test here while placing into UTM. So for concrete specimen was measured by LVDT, and the load was directly gained from the testing machine. So the result of the both testing and the result of the both LVDT and the UTM can be obtained into the graphic force versus displacement or P delta, and it will give different crack pattern for specimen based on diameter of rebar for composite specimens. So the next slide is about our result is crack pattern, P versus delta, stress strain, and tensile function or formulation, tensile strength formulation. The result from this experiment were divided into two kinds that are observable result and analysis result. From the picture below was crack pattern phenomenon that occurred along the tension test to prove the effect of tension stiffening while composite concrete or RC receiving tension force from UTM. So the next result is the analysis that will be explained what we already gained from the P versus delta into stress strain. Okay, here we comes to the stress strain and the stress strain intersection area in result and discussion sections. Here is the graphs where we'll show you about the between composite or composite specimen and bare bar, and the composite specimen and bare bar will be displayed in the graph, and the graph will be intersection, or there are point for the intersectional here, and we will be plot here in the area that will find the point of the first crack of the concrete. Here is the first crack of the concrete, determine the tensile strength of the concrete itself without any participation of the reinforced bar. Here we able to see the composite specimen A, composite specimen B, and composite specimen C, with the various result of the intersectional area. Here is the process we able to gain, and will process for the next steps. And the final result of formulation, here we are able to get the conclusion between root of FC prime or concrete compression test. We gain here in various result, and the first crack of tension of our composite specimens we able to get here. After that, we compare into the graph here, and we can able to see the values, and we formulate only the first crack itself. What we gain is 0.39 to determine the coefficient of the tensile strength for this method. So this is our result. There's 0.39, and the other 0.35, 0.5, and 0.64 for another comparison by methods of tension test for concrete. This experimental is purposed to create new method of concrete tension test. Meanwhile, many studies prove that tension in concrete is insignificant, but this experiment is also proof the contribution of the concrete tension stiffening was an important matter in RC composite. Several points will be described below. The first is the first cracking strength and post-cracking strength increase unsimilarly in specimen surface. This indicating different types of steel used and the strength of concrete of FC. From each force displacement curve, it was found that tensile strength capacity increased after specimen post-yield. The third, the contribution of tension stiffening is gained by finding the area of intersection between composite specimen and the bare bar. The fourth is tension stiffening. Tensile method give more accurate data to determine concrete tension strength than flexure and splitting test. Therefore, it won't make overestimate for concrete tensile strength. And the last is tension stiffening was one of the concrete tensile method which easier setup than the direct test and won't produce eccentric load as long as we have the setup test for our models. Thank you. This is our reference for our paper and our presentation today. And the last, thank you for your attention, especially for the committee for our presentation. See you next time, other occasion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.